This video is going to demonstrate how to calculate the band of investments method of calculating a cap rate. And so in our notes it's on this slide, and so I've copied the slide in here as well as the link to the example. So just to remind yourself, the problem that we're considering is that we can't, our situation is that we can't estimate a cap rate without actual comparable sales. So maybe in this particular case we don't have any comps, so we're looking for some other way, alternative way to estimate a cap rate. So what we can use is the band of investment technique, and the theory behind this is that since income producing real estate has both equity and debt financing, we can think of the cap rate as a weighted average of the cap rate both to the equity financing as well as the mortgage financing. And we're going to call that cap rate on the mortgage, that's known as the mortgage constant, which we'll calculate. So this is the formula for the band of investments method. And so the R, the cap rate, is going to equal the M here is equal to loan to value times the mortgage constant, or the mortgage cap rate, plus 1 minus the loan to value times the equity cap rate. And so we're going to call the equity cap rate the equity dividend rate, and again the mortgage cap rate is something we'll have to calculate. The equity dividend rate is going to be something that we're just given. You can treat that as a given figure. So if you were to click this link, you get the information that I have posted here for your convenience, and it's given us some example data of so that we can calculate an example band of investment method. So as highlighted in yellow, the data that we need to actually calculate it. The article of course goes into more detail about it, and I encourage you to read up on that. And then of course it kind of shows you the different components and then the solution. So what I'm going to do is going to shrink this down a little bit and then show you how this would be calculated. So here's my basic template. So again, we can think of the band of investment as being the weighted average of the debt financing and then the equity financing. And so we're looking for the debt return, and this is the most complicated step in the process. So what we want to do is calculate the mortgage constant, and the way that we're going to do that is we're going to solve for your monthly payment, but where you're using $1 as the loan amount. Okay, so we're going to use the payment function in Excel, and in just a second I'll show you how this would be done in the calculator. So you can use the payment. So it's asking for the rate. We see here that the interest rate is 5.5. So in Excel we're going to say you have to enter it like that, and then we're going to divide it by 12 because of course our mortgage is made monthly. The problem states we have a loan term of 25 years. So we're going to do 25 times 12, so we have 12 payments per year for 25 years, so that's our N. The present value, that's how much you're borrowing, but in this particular case, to find the mortgage constant, we're just going to put a 1 here, and actually a -1, so that our answer is positive. If you put a +1, you'd get a negative answer, so just for keeping the signs nice and tidy, we're going to put in a -1. And so now it's asking me for a future value. We're always going to put this at 0. We're contemplating a mortgage where we have no balance at the end of our 25-year term, so that's going to be a 0. And so we compute it, and so I'm going to change the format into a percentage, since that's kind of what we're talking, how we're contemplating this. And so this is my monthly cap rate, but like most of the time in real estate, we're going to be considering annual cash flows. So I'm going to take that result and then multiply it times 12 to get your annual cap rate. And so notice that this amount is higher than the interest rate on the mortgage, and that's because this is accounting for some of the principal that gets paid, some of the principal amortization. So our formula, so the mortgage constant, we can think of the mortgage constant as being the ratio of annual debt service divided by the loan amount. Sorry about that. So in that illustration, we'll show you how that makes sense. So say that I was going to, in this particular example, if I use the same information but then put in here that I'm going to borrow $100,000, I get an annual debt service of that much. So if I divide that by the loan amount, you get the cap rate on the mortgage constant. So what the mortgage constant does is any number times that percentage is going to give you your monthly payment, or in this case your annual payments. Okay, so that's why, since it's the rate that converts this cash flow as a ratio of that cash flow, in that case, in that sense, it's a cap rate for the mortgage. Okay, so that's just a little digression. All right, so we've got this all calculated for the debt return, and then for the equity return, the problem states that we have a equity dividend rate of 15%. So we put our 15% in there right there. Okay, and so our weights for these two returns are going to be the loan to value. So the problem states that we have an 80% loan to value, and then we have for the equity is just going to be 1 minus that loan to value. So 1 minus, oops. 1 minus that. Okay, so now we have both our returns and our weights for both the items, so now we can put it together. So for equity, it's going to be the return times, excuse me, I got this kind of flip-flopped. For the debt, it's going to be the return times the loan to value, and for the equity, it's going to be the return times 1 minus the loan to value, and then the weighted average, of course, is just the summation of those two items. Okay, so there we go. So I told you that we'd redo the cap rate calculation with the calculator, and so let's do that real quick. Shrink this down a little bit more. Alright, so here's our calculator. So again, check your payments per year. It's on 1 payment per year. I'm going to clear out the time value of money. And so now I'm going to enter my mortgage inputs. And so the N was 25 times 12. The I, my interest rate is 5.5%. So 5.5, remember it's different in the calculator than it is from Excel. Your present value is going to be, we're going to put in a -1, and your future value is 0, and compute your payment. Again, that's monthly, so multiply it times 12 to get your annual. And if we want to see more decimals, we can hit second format and increase this to 4 here, and then recall that payment times 12, 7.37, so you go the same way. Okay, so that's how you compute the Menem investments. And again, the major issue, or the most complicated part, is just calculating the mortgage constant, which again, all you have to do is solve for payment using $1 instead of your loan amount. Okay, so hope this has been helpful, and see you back for another video some other time.